Today we'll discuss node progression in three-phase locos. So what is node? So before that we can see the block diagram. Here this is in locomotive we have two VCU, VCU1 and 2. So VCU only controlling all the operation of locomotives. This is a master processor. Master processor will be there in VCU, that is FLG. So this FLG communicating with the different processors in SR, bar and other subsystems, and it takes the healthiness of other subsystems and other what stage it is there, what are different processors in what operation it is doing, what is the status of the other subsystems, that will be monitored by FLG. So depending on that, FLG will give some nodes. FLG. So node means subsystems are doing some operations. Na? So status of that operation, which will give the node. Means that operation stages only it will give. So like initial booting and the communication between the processors and the locomotive operation, like that stages only it will give. So these are the nodes. 0, 1 means start node. Start node means after switching on battery BL key, first node is 0, 1. Means control electronics activation. Second one 0, 2, vehicle bus monitoring. Vehicle bus means the subsystems are communicating through the MVB bus. So that MVB bus communication working of that bus is monitored. That is doing through this node only. Second node, it will check the condition of the buses, MVB buses. If it is okay, it will go to next node. Otherwise, it will give the issue fault. Means depending on, suppose that the communication between the SR1 is having some issue, then it will give the message lifetime missing from SR1, like that. Next is 10. 10 means in 10 FLG will give the command to SLG 1 and 2 for starting their SLG working. Means SR, it will give command to SR to do its operation, in initial operation. Then 13. Similarly for 10, one more operation is there. MCU start switching off timer. Means MCU will VC will switch off immediately. It will not switch off. It is having some timer. That timer switch off timer. That timer will start in node 10. Means before switching off the system, it will give some delay. Means some data it has to save and safely it want to shut down. So immediately it will not get shut down. So for that some timer is there. It will start the timer in node 10. Then 13. 13 means MCU switch off condition. Once that timer is started, after ending the timer, MCU will switch off. That is node 10, 13. Then 70. 70 means whenever priority 1 fault is happening, then FLG will take the protection action, like VCB want to open, like that. So in that condition, it will go to 70th node. In that condition, VCB during priority 1 fault, VCB will off with the disturbance or with or without a VCB off. Then 71 node is FLG ready for acknowledgement. Whenever priority 1 fault is happened, FLG will take the corrective action for open the VCB and it will stop the working of SLG, means SR, and it will wait for the acknowledgement from driver. So that is the 71st node. So after getting driver acknowledgement, it will go to next operation. Then 110. 110 means actually these all are SLG1 and SLG. ALG is the processor in SR. It is there in older GTO system. Now all are IGBT SR. One processor will be there, SLG. So which means this in 110 node, FLG will give the command to SR that SR peripherals will be there, like gate drive cards will be there, and feedback. It is taking feedback from different motors and transformer like that. So SLG want to check the healthiness of other peripherals like transformers and other sensors and gate unit driver like that. So in this node, it will FLG will give the command to SR that it will check the peripheries of SR. If it is okay, it will go to next node. Similarly, all these are peripheral tests of SL2, SRG, SR2. This is SR1, this is SR2, and 310 and 320. These are the release commands to SLG1. Means SR processor only for starting the gate pulse and all. Next is 390. After checking all these, SR will give the readiness signal in 390. Next is 503. In 503, Loco will be ready, but cab not active, like that. So in 504, cab will get activated and BL key will be in driving position. Already BL is in driving position, and after all these operations, it will come to 504 node. In 504, MU during MU, if it is slave Loco means it will ready for slave operation, or master means it will ready for master operation. Next is 550. In 550, what we are doing is switching on the BLPT. So after BLPT switching on, it will come to 550 node. Then supply will go to Pando circuit for raising the Pando. If it is successfully raised the Pando, what will happen? OHE voltage we can see in UA meter or display DD. Next is 550. In 550, it will give the after switching on BLDJ, it will give the supply to VC will give the supply to VCB coil. Okay. So that is the 550 node. If it is successfully finished, closed to the Pando, it will take the feedback from VCB interlock and it will go to next node. In 550, 570, VCB is closed already. Then 580. In 580 node, FLG giving command to SR that to start the gate pulsing. These are for SR1 and SR2. Next, 583. In 583, in SR, what is there? Two conductors will be there. One is pre-charging conductor, another one is main conductor. So first, DC link will charge through pre-charging conductor. So first, pre-charging conductor has to close. So 583 node pre-charging will happen. Then in 584 and 585, main conductor will come. In 590, DC link voltage will build up to 2800. Five 92 node, if harmonic filter is there, it will give the commands to conductor. In harmonic filter, we have three conductors: 8.1, 8.2, and 8.41. So this conductor operation will take place in 592. Then in 594, pulsing will start. In 596, inverter module will give the supply to transformer, not transformer, traction motor. In 596, the track to effort will be developed according to the throttle position. In 600 node, it's a fault node. In that, the VCB will switch off and the fan will get down. 601, loco will get shut down and the DC link voltage developed in SR will de-engage. In 605, DC link voltage is too low, means this node is there, 605, and again precharging will take place. Whenever DC link is reduced, precharging has to come again. 612 node, earlier we see na switch off timer. Again this timer getting started. 613, the MCU will get switch off FLE. In 700, whenever any fault is there, then VCB will get switch off without any disturbance. 701 is loco ready. If any fault has came, after acknowledgement, again loco will become ready for service. So in 701, loco will get ready. 710 is disturbance with the VCB off. So this is the disturbance without VCB, and this one disturbance with the VCB. So 715 also loco ready for VCB on. After any fault happen, after acknowledgement, loco can be run further. In that case, loco will become, after acknowledgement, loco will become ready for VCB switch on. In that case, 715 will come. 716 is protective shutdown through SR. If any problem is there in SR, this will give the process, FLG will give the node 716 through SR protection. That's all.